Okay, scientific notation. Scientific notation is a notation, a way to write numbers in a more manageable format. And scientists use this notation to write either very big or very small numbers because they're always working with numbers with many, many zeros, the distance from here to the sun, the distance between planets, or the distance between atoms. So a positive number, when it's in this form, is considered to be in scientific notation, okay, where A is a number in between 1 and 10, okay, like this. So you've got to have, this number has to be 1 through 9 inclusive with a decimal, right? Between 1 and 10, including 1, but not 10. And N is an integer, right? Integer means it can be positive or negative. Okay, if N is positive, the number's going to be a whole number, a very large number. If N is negative, the number is going to be a decimal less than 1, a small number, right? So think about your numbers. Positive numbers go this direction, oh, a big number. Negative numbers are this direction on the number line, little numbers. To convert a number from scientific notation to decimal notation, write all the digits. So let's do an example here. Let me get me a pen. Write all the digits of the numeral without the decimal point. Okay, and then we're going to move that decimal point in places. So in this case, 5 places. To the right if it's positive, and positive numbers, again, if you're thinking about a number line, right? Positive numbers are to the right. So because this is positive, I would move that decimal point 1, 2, 3, 4, 5. That means it's going to be 1, 2, 3 places past the end of the number. So I need 3 placeholders. Okay. If it's negative, we're moving the decimal point to the left. So you write all of your numerals without the decimal point. And then this is the negative direction, so I'm going to move that decimal point 1, 2, 3, 4, 5, 6, 7, 8 places. It's going to wind up right there, meaning there needs to be 7 zeros to make this move 8 places in front of the 5. 1, 2, 3, 4, 5, 6, 7, and then there's your decimal place. Okay, so this is the number in scientific notation, and this is the number, and it can either be called standard notation or decimal notation, just a regular decimal number. If you want to put a 0 in front there, you may. Your homework probably will. Okay, and if you don't see the decimal, it's indicated it's at the end of the number, right? A decimal at the end of the number we don't have to write. Okay, so let's try that again. Let's say we had 2.3 times 10 to the 9th. Think about this. This is going to be a large number. So I'm going to move that decimal point this way 9 places. Well, here's 1 place right here. So I just need to add 8 zeros. Right? Okay, so now you can see how this number is a lot easier to work with than this number. Now, what if we started out with a number in standard or decimal notation, and I want to write it in scientific notation? Okay, so all the non-zero digits is what we're going to put first. A decimal after the first one. So this number has to be between 1 and 10. And then it's always times 10 to some number. I know this is going to be a negative number because look, this is a little bitty number, a decimal number less than 1. So this will be negative. And all I do is count how many times I put the decimal right here. Let's even change the color. I put the decimal right here. So how many times did it get moved from here to there? 4 times. Okay. Let's say we start out with 525 million, and I want to write it in scientific notation. The non-zero digits get written with a decimal after the first digit, and then it's always times 10. Because this is a large number, this number is going to be positive, and I just figure out the decimal starts out right here in this number because there's no other decimal anywhere else, and I want it to be right here. How many spaces is this? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so back and forth from scientific to decimal notation. Now let's show why this might be useful to scientists or make your math easy to do. So this, if I wanted to divide this might be a pretty hard thing to divide all these zeros and a decimal up here. Now we've already talked about how we can't mix fractions and decimals, so I can move it here, but then I'd have to move it way over here. I'd have 8 divided by this giant number. So an easier way to do that is, let's write both of these in scientific notation. Now this, all the non-zero numbers get written, and that's the only non-zero number, so technically your decimal is going to be right there. It's going to be times 10, because this is a small number less than 1, I know that's going to be negative. Now, to move the decimal from here to where I've put it is 1, 2, 3, 4, 5 places. Okay, now down here, once again, we still only have one number. I'm going to put that for emphasis, right? But now I'm going to have a positive number on my 10 because this is a large number, bigger than 1. Okay, it starts out right there. I want it to be right there, so that's 1, 2, 3 places. Okay, so now, because everything's multiply, this I can divide. Oh, that's 8 divided by 2. And also we know our rules for dividing exponential numbers with the same base, right? So you can either make this, lots of options here. Now what we said before was anything that has a negative exponent, change its place to make it positive. Okay, now 5 tens times 3 more tens, altogether that's 8 tens. Or you can follow your rule that says subtract the exponents. Now these are the same thing, remember. Okay, but if I'm using scientific notation, I want the one with the negative exponent. I don't want a fraction there. It's got to be times 10, not 1 over 10. So even if I used this method, I still know, okay, I really need that to be in the top, and how you move from top to bottom is you change the sign. Okay, so that made my math easy to do, and now I can just change that number. Oh, it's going to be a tiny number. Here's the decimal. I need to move it 8 places in the negative direction. So here's 1 place. I need 7 zeros on that thing. 1, 2, 3, 4, 5, 6, 7, 4. Okay, so able to do this math way easier. And once again, all of this was just an aside to refresh our memory. Really, here's our steps. Here, here, here.